2023 was the worst wildfire season in all of Canada's history, burning more than 18.5 hectares of land, an area larger than Greece, displacing more than 100,000 people. Every decade, wildfires occur 6% more and end up burning 7% more land due to climate change. Last year when I was in Alberta, we were recommended not to go outside because the smoke from the wildfires was literally harmful for us. That's how bad wildfires can get. Taking this into account, I decided to create a machine learning model that can predict the spread of wildfires. I trained this model on nearly a decade worth of data and managed to achieve 89% accuracy. Hey, my name is Displacing and I'm a 16-year-old programmer from Canada interested in AI and space technologies. And today I want to show you the technicals of my wildfire spread prediction model. The dataset I used is also available on Kaggle, but it essentially contains 64 by 64 kilometer regions as samples, and within those samples it has various environmental factors that influence the spread of wildfires. The core information relies in the fire masks, which represent where the fire is within the 64 by 64 kilometer region. There are two fire masks, one for where the fire was initially and another fire mask for where the fire has spread within 24 hours. We also need to consider the spatial context of the wildfire, and we can do so by labeling each pixel within the fire mask, so each pixel that is on fire as 1 and each pixel that isn't on fire as 0. This way we can find the average of each pixel based off of its neighbors to determine the intensity of the fire in that specific location, which would be a number between 0 and 1. This new number between 0 and 1 will represent the shade of red and also the intensity of the fire. This new fire mask contains spatial information that we can use as input for the linear regression model. Now for the linear regression model, imagine vertically stacking all the various environmental factors that influence a wildfire on top of each other. Based off of each pixel within that 64 by 64 kilometer region, you can predict whether that pixel would be on fire or not. And that's where the linear regression model comes in, where it learns the patterns between whether there is a wildfire in this specific pixel or not. To evaluate the model, I use k-fold cross-validation rather than just normal cross-validation, because k-fold cross-validation allows you to better understand and evaluate the generalization of the model rather than just splitting the dataset into testing and training data. You split it up into various samples. So I use 10-fold cross-validation, which basically allowed me to split my dataset into 10 samples. The model was tested on each of those 10 samples, and there was one specific sample that was left out specifically to test. Then the accuracy of each sample, including the testing sample, is averaged to find the overall accuracy of the model. Overall, so far, the model has managed to achieve 89% accuracy. This means that 89% of the time, this model can predict where a wildfire would spread based off of various factors like vegetation, drought index, temperature, humidity, precipitation, and etc. In the future, we can scatter sensors across fire-prone areas and then use this model to predict potential wildfire spread. These predictions can allow us to trigger immediate action so we can save lives, protect properties, and minimize environmental damage. If you found this interesting, make sure to follow me on Twitter, subscribe to me on YouTube, and check out my Substack for monthly updates on the projects I build. And for now, I'll see you next time when I build something related to satellites.